Let's tour the characterization labs on the second floor of the Nanoscale Research Facility. This room is one of 3 laboratories that's dedicated to particle characterization and analysis. At the far end of the bench is the pyrometer. This measures the distribution of through pores by liquid expulsion. It also has the capability to measure gas permeability. The rest of the equipment and tools on the bench are used for sample preparation to use the AutoSorb. The AutoSorb is a high-resolution gas sorption analyzer that is used for the characterization of active surface area, heats of absorption, percent dispersion, and average crystallite size. Behind the AutoSorb, we can see the Fourier Transform Infrared Spectroscope and Microscope, or FTIR for short. Can be used to identify surface and bulk compositions of many materials, including gases, liquids, solids, fibers, and thin films. On the left, the Contour GT-I is a versatile benchtop optical surface profiling system that can measure surface topography from 2D and 3D with high accuracy in a range from fractions of a nanometer up to approximately 10 millimeters. Moving down the hallway, we're going to go into the second lab. The second lab houses the Contour LS320 that measures particle sizes from 40 nanometers to 2,000 microns by laser light scattering. It is based on the principle that light intensity scatters from particles is a function of scattering angle, particle size, shape, incident wavelength, and response of the materials to light. Next, we can see the Aerosizer. It measures particle size distributions of dry particles or aerosolized liquids in the range of 0.2 to 700 microns by aerodynamic time of flight. Last up, we have the freeze dryer, which allows liquids to be removed from samples by sublimation. Now, heading across the hallway, we're looking at the Advanced Manufacturing Lab, where you can find a clean environment bench for manipulating samples without being exposed to air particles. Now, just to the right of this bench, we have the PDMS preparation area. The PDMS is used to create an optically clear film on the surface of a wafer, typically used as a see-through layer for microfluidic devices. Up next is the Object 260 3D printer, which is capable of high-resolution printing of several different materials. It can also blend materials to create a wide spectrum of material properties for desired applications. As we head out the door, you'll see our glove box, which is used to clean the 3D printed parts. As we head down the hallway, let's all say hi to Gary. Hi, Gary. Going across the hall in the sample preparation and microscopic lab, we have several options for conductive coatings on samples used mainly for scanning electron microscopy. Carbon evaporation and gold palladium sputter coatings are the most requested coatings. The Hitachi S3000 is a compact scanning electron microscope with a standard tungsten filament. It can image up to 100,000 times, and it has an EDS detector for elemental analysis. As we move out of the lab, we go across the hallway to the third particle characterization and analysis lab. This lab has a viscometer, which measures the viscosity of a liquid at a fixed rate. On the left, you'll see the mercury porosometer. It's used to measure porosity of a material by applying controlled pressure to a sample immersed in mercury. Moving back to the right side of the room, you'll see a Zetasizer. This instrument allows for the measurement of particle and molecular size with the ability to analyze particle concentration of monodispersed samples below 500 nanometers. The Atomic Force Microscope, or AFM, it's a high-resolution nanometer scale type of scanning probe microscope. A stylaser probe is moved across a solid surface following the contours of the topography, and it provides a 3-dimensional image of the surface. Last in this room is the UV-Vis spectroscope with integrating sphere. It's an analytical technique that measures the amount of discrete wavelengths of UV or visible light that are absorbed by or transmitted through a sample in comparison to a reference or blank sample. As we move out of the room and we come down the hallway, you'll see that we have another collaboration space for students, staff, and faculty to get together on the second floor and discuss any of their projects or research. Coming up next, on the left-hand side, we have the Microanalysis Lab. An electron probe microanalyzer, or EPMA for short, is an analytical tool used to non-destructively determine the chemical composition of small volumes of solid materials. Concentration of elements from lithium to plutonium may be measured at levels as low as 100 parts per million. Next up is the Tuscan Meta3 scanning electron microscope, which is equipped with EDS for elemental analysis and an electron backscatter diffraction detector for crystallographic analysis. So coming out of the room, we got a bit of a walk down the hallway. So we make a right-hand turn, and then we walk all the way down to the left is where we make our next turn. The next lab that we're going to is called the Surface Analysis Lab, and it houses instruments for the analysis of the top atomic layers in the surface of a sample. The lab consists of two X-ray photoelectron spectroscopy systems, or XPS, and an Auger electron spectroscopy system, or AES. Coming out of this room, we're going to move on to the final room of this tour. The last room on our tour houses the X-ray diffraction lab. It's got two X-ray systems. There's a material research diffraction system for specific analysis such as rocking curve analysis and reciprocal space mapping, and a powder X-ray diffraction system which is used for phase identification and quantification analysis. The lab also provides specialized software for data reduction and analysis. This officially concludes the tour of the Nanoscale Research Facility. Let us know if you have any questions. We really appreciate your time. And as we often say in the nano world, thanks for almost nothing.